So, hello everyone again, this is lecture 4 part 2 of alternating current. In the previous lecture we have completed with the discussion regarding resonance. In this part we will move on with the further subtopic of resonance, which is sharpness of resonance, in which we will understand different topics such as bandwidth, quality factor, etc. So, it is also a very important topic. Let us try to understand that and then we can move on to the next subtopic or next understanding of power factor. So, that thing being said, this is lecture 4 part 2 of alternating current. I am Sameer Lavankar. Let us begin our discussion. So, currently we are on the sixth topic only, in which we are trying to understand resonance, and today we will try to understand a new concept which is basically sharpness of resonance. Okay. So, sharpness of resonance, let me first write a few things so that I can make you understand what do you mean by sharpness of resonance. Okay. So, basically what is the value of current being obtained in the series LCR circuit? The current being obtained in a series LCR circuit is always equal to Vm upon capital Z. It is equal to Vm upon capital Z, and if I try to write the exact value of capital Z, it is nothing but equal to Vm upon root over R square plus Xc minus XL whole square. If I write it in more general sense, it is nothing but equal to Vm upon root over R square plus 1 upon omega c minus omega L whole square. Okay. This is the value of current being obtained, right. Now, when it is maximum? It is maximum when omega is nothing but equal to omega naught, and the value for which we are obtaining this omega naught is nothing but equal to 1 upon root L c, correct. Therefore, the value of I m max is nothing but equal to V m by, let me write it as Z min first, which is nothing but equal to V m by capital R. Okay. So, this is the basic concept of resonance which we have understood till this point. Now, let us try to understand another concept. So, if you look at this diagram very carefully, apart from the frequency omega naught, for all different frequencies apart from omega naught, let us say if I tell about this frequency, which is let us suppose we are talking about, let us say this frequency, which is 0.75, correct, or let us not go into that direction, let us say I make a horizontal line at some location. So, for each horizontal line being made or each value of current, I am getting two different values of omega. I am getting two different values of omega. Apart from omega naught, if I make a horizontal line anywhere else, every time I am getting two different values of omega. Okay. Let us try to understand more about these two values of omega which we are trying to obtain. One thing more, let us say I denote this value of omega as omega 1 and I denote this value of omega as omega 2. Every time this omega 1 and omega 2 are in some sort of related. How it is related? It is basically related as in this way. Let us say I write this as omega 1 and I write this as omega 2. Okay. So, if you see clearly, omega 1 is nothing but equal to omega naught plus some delta omega, correct. So, this is the value of delta omega, and because it is symmetric, I can write this value of omega 2 is nothing but equal to omega naught minus delta omega. Okay. Let us try to understand this scenario now. Okay. So, what was I saying? So, basically except omega is equal to omega naught for all values of current, there exist two different frequencies which offer same amount of or same value of current Im. Okay. So, for value omega other than omega naught, the amplitude of current is less than the maximum value, and suppose that we choose a value of omega for which the current amplitude is 1 by root 2 times its maximum value. So, okay. So, let us choose some value. So, let us choose a value of omega for which the why am I doing this, you will understand when the complete mathematical portion is over. So, let us choose a value of omega for which the current amplitude is 1 by root 2 times its maximum value, is 1 by root 2 times its maximum value. Okay, so, this is one of the assumption which you are trying to understand now. So, at this value the power dissipated by the current becomes half. So, power dissipated becomes half. Okay. Now, let us try to understand that same concept only. So, from the curve which I just explained to you, which was regarding two different values, let us try to understand that let us suppose that there are omega 1 and omega 2. So, we are trying to assume that two different values of omega such that, or let me first write that line also. So, let us suppose or let us assume two values of omega obtained as omega 1 and omega 2. Okay. So, if these are two values of omega 1 and omega 2 which are symmetrical about omega naught, which are symmetrical about omega naught, we can write omega 1 is nothing but equal to omega naught plus delta omega, and omega 2 is nothing but equal to omega naught plus omega naught minus delta omega. Okay. I hope it is clear till now. Now, there exists a term, let me change the color. Okay. So, now this difference that is omega 1 minus omega 2 will be what? It will be nothing but omega naught plus delta omega minus omega naught minus delta omega. Omega naught being cancelled, this is nothing but equal to 2 times of delta omega. This value of 2 times delta omega is nothing but called as bandwidth of the circuit. This is called as bandwidth of the circuit. Okay. So, I hope this concept is clear to you. Now, let us try to understand another definition, which is sharpness of the resonance. Okay. The quantity omega naught upon 2 delta omega is regarded as a measure of sharpness of resonance. Let us try to understand the logic of why we are trying to say that why this quantity is said to be regarded as a measure of sharpness of resonance. So, let us look at this diagram. So, if you look at this diagram very carefully, this is the value, just look at this blue diagram once, do not look at this grey diagram. So, if you see clearly what is the value of omega naught being obtained here. So, the value of current is having the maximum value at this point. Okay. Let us say I make two different horizontal lines. I make one horizontal line at this location and I make one horizontal line at this location. Okay. So, you may have heard of the terminology in which we say that we try to more sharp the image, more it looks that the quality of the image is better. So, if you try to change the focus the amount of sharpness increases or decreases. When the amount of focus being obtained is very close to the amount of image being processed, then the sharpness of the image increases. The same concept is also being applied here. So, we are basically saying that, and as we are close to this value, as and as we are close to this value, the amount of sharpness of the resonance will be higher. As and as we are far from this value of omega naught, the value of sharpness will be lower, correct. So, now look at this very carefully. Omega naught is a constant, omega naught will not vary, it will be only a material value because it is always dependent on only L and C. The value of 2 is also constant, the only and only thing which is varying is nothing but delta omega. So, if it is only delta omega, if you look at this horizontal line 1 and horizontal line 2, the horizontal line 1 is having this value as delta omega and horizontal line 2 is having this value as delta omega. So, it is quite clear that as the value of delta omega is smaller for 1, the amount of sharpness or this measure of sharpness is higher for the 1 value as compared to second value. So, as we are trying to go very near to the value of delta omega, the sharpness of our resonance is increasing. So, this can be directly analogous to the sharpness of image being increasing as we try to keep the focus to the exact focus we want. So, let us say we try to say that the value of focus we required is f naught. As and as we are close to that value of focus, the sharpness of the image increases. The same analogy can be put forward here. As and as close we are trying to go towards value of omega naught, the sharpness of the resonance increases. So, sharpness is mathematically said as omega naught upon 2 delta omega. So, as the value of delta omega is smaller and smaller, the value of sharpness increases. When this value of delta omega is 0, the sharpness is infinite. Okay. Fine. So, that thing being explained, let us move forward now. So, bandwidth is explained to you and sharpness of resonance is also explained to you. So, I will just write whatever I just said. The smaller the value of delta omega, the sharper or narrower is the resonance. Okay. Next thing is, so now let us understand this value of delta omega more. So, similarly I can also write, so the higher the value of delta omega, we can say that the sharpness is much and much less. Okay. Next concept now. So, to get an expression of delta omega, we note that the current amplitude I m is what? So, current amplitude I m is nothing but equal to 1 upon, please understand this, 1 upon root 2 times I m max. Okay, because this was a basic assumption which we assumed in the starting only, just in the previous slide, for omega 1 is equal to omega naught plus delta omega, right. So, therefore, what we can write? Therefore, we can write that at omega 1, what is the value of I m? I m is nothing but equal to V m upon root over r square plus x e minus x l whole square. Try to understand this very clearly, because now a lot of mathematics is involved here. I will go very slow. Okay, so first of all, I m is nothing but equal to V m upon under root of r square plus x e minus x l whole square. Let us try to write the exact value here. So, it is nothing but equal to V m upon under root of, so that our revision also keeps on happening. So, it is nothing but 1 upon omega c minus omega l whole square. Okay. This is nothing but equal to, I just wrote it down, that is I m max by root 2 for value of omega 1, correct. which is nothing but equal to Vm by capital R, because at the value of maximum value Xc is equal to XL, and therefore the value of impedance being obtained is nothing but equal to capital R. Therefore, in the place of Im max I can directly write Vm upon capital R root 2. Okay. I hope it is clear till this point. Now, let us try to understand more. In the place of what else we can write here. Okay, so these all things are okay. Next thing is in the place of R root 2, next thing we can write, if you try to equate this above quantity and below quantity, we can so from equation number 1 and equation number 2, what we can write. So, basically those are same equation only difference is that for 1 upon omega c minus omega L, this was equal when it was equal when omega is equal to omega naught, but we are talking about omega 1. Please do not get confused here. Okay. I will try to make you understand again. So, I am at value of omega 1, we are trying to calculate the value of I m. Simple equation states that what is the value of I m? I m is nothing but equal to Vm by capital Z. Vm by capital Z can also be written as equal to Vm upon under root of R square plus Xc minus XL whole square, correct. But the initial assumption was that the value of current being obtained at this value of omega 1 is nothing but equal to I m max by root 2. Now, this I m max is nothing but equal to Vm upon capital R. Okay. So, if it is equal to Vm by capital R, basically the value of current, that is equation 1 on equation 2 on RHS is same. If Vm is same, we can basically equate the denominators. Okay. So, let me just equate the denominators now. So, equating the denominators, we get root over R square plus omega 1 L minus, please remember it is omega 1 C whole square is nothing but equal to R root 2, correct. Let us square both sides. So, we will get R square plus omega 1 L minus 1 upon omega 1 C whole square is equal to R square into 2, correct. Let us put R square on this side and then again calculate. So, it is omega 1 L minus 1 upon omega 1 C whole square is nothing but equal to R square. Let us remove the squares. So, we will get omega 1 L minus 1 upon omega 1 C is nothing but equal to R. Okay. So, this is the final equation we obtained for a relation between the resistance and the value of omega 1, when the value of current being obtained is nothing but equal to I m max by root 2. Okay. So, this is the first equation which is of significance for us. Let me stop it here only, because a little more understanding is required, as in how to calculate exactly the value of delta omega being obtained for a particular current value. So, let me stop it here. Now, I will just calculate, after this I will just write value of omega 1 is nothing but equal to omega plus delta omega, and then we can move forward into understanding what is the actual quality factor and so on. So, let me stop the discussion here only. We will meet in the next part in which we will understand quality factor, and then we can move on to the next concept, which is your power factor. So, let me stop it here. Thank you so much.